In K, we formalize the process for solving word problems somewhat. We follow the same series of steps, analyze the story and build a model to represent it, make a numerical expression to solve the problem, evaluate this expression to complete the solution, that is, complete that equality, and then write the answer. And so those steps are shown here, or some of this, so let's sort of go through it. 4 purple monsters and 3 orange monsters. We're riding a roller coaster. How many monsters in total are riding a roller coaster? So there's the problem statement up top in that picture, and you can see one of the ways that we develop the difficulty is how clear the picture is. In this case, the picture is already a concrete model, right, because there the monsters are in a row. And so the specific activities we give the children are, there are 4 purple monsters, paint 4 circles purple. Then there's something very interesting, and that's what is represented in the left-hand slide here. We say, do we need to add more tokens or cross some tokens out? And the student has to click on the plus sign or the minus sign. This is trying to model the thing that a teacher would do in the classroom when they're working with a student to build a token model and just say, okay, do we need more? Should we use another color? Should we take some tokens away? And so this is something that was pretty intensely debated, how exactly we should do this. Should we let them build a wrong model? And what we decided to do was just always ask, well, should we cross some tokens out or add some more tokens, and let them answer by clicking a plus or a minus sign, which seemed like an acceptable way for them to answer because they're also indicating whether we should add or subtract to solve the problem. So after the student says, or we help them to see that they should add, then we say, great, paint 3 more tokens orange. That completes the model. And then they have to show 3 plus 4 equals 7. And notice in this third screen, if they get 3 plus 4 right, but not 7, then we'll show them that number house, and you can see the relevant rows are highlighted to remind them that 3 plus 4 is 7 and ask them to just try again with the right-hand side. On the other hand, if they make a more fundamental error, then we'll have a longer discussion where we say, well, first there were 4, how many purple tokens are there? Okay, 4, drag the number 4. How many orange tokens are there? Great, drag the number 3. Do we need to add or subtract? We need to add, and then what's 4 plus 3? And then finally, folks who are familiar with our Foundations curriculum should not be surprised that we always write the answer to a word problem separately. We have a solution and an answer. And so you can see we have a unit there. That picture is a unit. So the answer is 7 monsters. And the student drags the 7 from the solution line to make the answer. So problems start to include more complex calculations. There are 10 clouds in the sky, 8 of them are rain clouds. How many clouds are not rain clouds? This is also an example of a different type of word problem and a different type of model. So you'll see it's the same sequence of questions. Okay, let's paint 10 dots for the 10 clouds. Now do we need to add more dots or paint more tokens or cross them out? This time the student should answer that we cross them out. And the student can click on the tokens to cross them out. We allow the student to cross out any 8 tokens, but we'll sort of, and count it as correct, but then we'll kind of clean it up for the future exercises so that the 8 on the right are crossed out. Once we have the model, the logic is the same. We have them build an equation to make the solution, and then I drag the answer, and you can see there's a little picture of a cloud for the unit. There would be some scaffolding if they get the calculation wrong. Students solve some new types of word problems, such as finding the difference between two quantities, finding the bigger or the smaller quantity. So this is something that's quite subtle. So in this problem, Ruby flew 5 kites. Maya threw 4 more kites than Ruby did. How many kites did Maya fly? The solution is going to be 5 plus 4 equals 9. But the model is different because, let me just go back 2 screens. To a child, this problem with the monsters is not the same type as this problem where we are comparing different quantities, because it's comparison, right? We have 4 more. So the way we make models for more than and less than, as you can see here, well, first we make 5 dots for the Ruby's kites. Then we know Maya had as many and 4 more. So first we make as many, and then we say, okay, do we need to add more or cross them out? Well, it's 4 more, so we need to make 4 more. And then the final piece is the same as other word problem types. We make 5 plus 4 equals 9. We would show a number house if they made a mistake, etc.